our planet, Earth. From space, it might seem static, unchanging, but beneath the surface, it's a world in constant, powerful motion. The very ground beneath our feet isn't one solid piece, but a mosaic of enormous, rigid slabs. This is the theory of plate tectonics. It explains that Earth's outer shell, the lithosphere made up of the crust and the rigid upper part of the mantle, is broken into massive pieces called tectonic plates. These plates float on a hotter, softer layer of the mantle called the asthenosphere. Driven by immense heat from Earth's core, these plates are constantly moving, albeit incredibly slowly, typically just a few centimeters per year, about the speed your fingernails grow. But where these colossal plates interact, at their boundaries, the most dramatic geological events on our planet occur. Mountains rise, volcanoes erupt, oceans are born, and earthquakes shake the land. In this video, we'll explore the three main types of plate boundaries and the incredible forces at play when they interact. But what drives this monumental movement? The primary engine is mantle convection. Intense heat from Earth's core warms the lower mantle, causing this rock material, over geological timescales, to behave like a very thick fluid. Hotter, less dense material rises. As it reaches the base of the lithosphere, it spreads out, cools, and eventually sinks back down towards the core, creating massive, slow-moving convection currents, like giant conveyor belts within the mantle. These currents exert a powerful drag on the overlying tectonic plates, pushing and pulling them across the planet's surface. Other forces like ridge push, where gravity causes plates to slide away from elevated mid-ocean ridges, and slab pull, where the sheer weight of a cold, dense sinking plate pulls the rest of the plate along, also contribute significantly to plate motion. Let's first look at divergent boundaries. This is where two tectonic plates are moving away from each other. As they separate, immense cracks or fissures open up in the lithosphere. There are two main types of divergent boundaries. When divergence happens between two oceanic plates, it leads to seafloor spreading. Magma from the asthenosphere wells up to fill the void created by the separating plates. This molten rock cools and solidifies upon contact with the cold ocean water, forming new oceanic crust primarily made of basalt. This process continuously creates new seafloor, building vast underwater mountain ranges called mid-ocean ridges, like the Mid-Atlantic Ridge. These zones are also characterized by volcanic activity, though mostly underwater and frequent relatively shallow earthquakes. Hydrothermal vents, supporting unique ecosystems, are common features here. Divergence can also occur within a continent. Here, the continental crust is stretched and thinned, causing it to fracture and break along large faults. Blocks of crust can sink between these faults,